Hello, my name is Alexey Vodka, and today I am going to speak about algorithms and methods for comparing microstructures of material based on their images. The main problem is to develop the image processing algorithm for automatic identification and analysis of individual grains within the material microstructures, comparison the characteristics between generated and experimental microstructures. These objectives lead to next tasks: to develop the algorithm for automatic grain identification and characterization, to conduct comparison characteristics between generated and experimental microstructures, test algorithm on real and synthetic microstructures, to analyze the distribution of grain characteristics for microstructure comparison. On this picture, on the left you can see the artificially generated microstructure, and on the right you can see the experimental image obtained from lightning microscopy. Um, there is a well-known analog for image processing tool like a Climax or Fiji and others, etc. They have similar functionality, but it's very difficult to optimize this processing for big amount of data, and they not deal with specific format we generated for 3D microstructure like Matvis 3D. So this important to develop own algorithm with own program implementation of such algorithm. In general pipeline, we can see that our algorithm contains the next steps. So first of all, we got a 3D generated microstructure using Matvis 3D software and split it on the layers. You can see the next step. After that, we developed the algorithm which process segmentation and measurement of each grains and calculate the grain characteristics. After that, we collecting this data and find or calculating the descriptive statistics of such characteristics and compare the experimental data with this artificially generated using violin plots that you can see on the bottom of this picture. In general, we use the next characteristics of the grains, like normalizing grain area, equivalent circle radius, momentum of inertia, shape factor, scale factor, aspect ratio for rectangles areas, and normalize it in inertia tensor like 8 by equation, defined by equation 8 and 9. When we calculate this characteristic, we perform the mathematical or descriptive statistics calculation. We use mathematical mean, variance, and mode to calculate the main characteristics. Also, we calculate the range and the IQR like quantile 3 minus quantile 1. To assess the accuracy of our development algorithm, we test this algorithm with general simple images, like a figure, like it's shown in figure 1, figure 2, figure 3, and figure 4. Figure 1 and figure 2 just shows rectangle-like images, and figure 3 and figure 4 for circle-like images. And we obtain the next characteristic for these images. You can see the error of estimation of such characteristic in the table on the bottom of this slide. And the main problem that occur is characteristic which deals with calculating the perimeter of circle. This characteristics leave more than 15% error in estimation of such characteristics. After that, we use approximate this statistic characteristic using violin plot. We use aspect ratio distribution. You can see the blue one is the artificially generated one, and the green one is obtained from analyzing the real one microstructure. And on this slide you can see aspect ratio distribution, scale factor distribution, shape factor distribution, and equivalent circle radius. After that, we'll also calculate the orientation of angle of orientation distribution, moment of inertia, an x direction and xy direction, and normalized grain area. After that, we also calculate the compactness ratio distribution, ratio of area to the grain axis, and ratio of the main moment of inertia to the grain area, and ratio of the moment of inertia between axis to the grain area. After that, we can say that all of such objectives have been attained and yielded significant results to conducting the advancement of image processing metrology and analysis of material microstructure. The results obtained are important steps for the development of image processing method and virtual recognition of grain microstructures. All algorithms have been tested and the error has been estimated. Thank you for attention.